Hey everybody, here's a quick video on the first part of the Math Excel for 3.2. On 3.2.1 it says solve the system of equations using substitution. Your first equation given is 4x plus y equal 24, and your second equation is y equal 4x. The reason I circled the y is because this is already solved for y and we're going to substitute that in. So I start writing the 4x plus something equal 24, and then in place of y I put 4x. So I have 4x plus 4x is 8x, 24 divided by 8 is 3. So I get x equal 3. And then to get y, I do 4 times 3 and I get 12. So we get 312. So basically, as a quick comment about this section has to do with substitution and elimination. We just got done solving it by graphing on 3.1. So you need to follow the instructions they give you as far as how to solve it. But if you were completely stuck, like on a test, you could use any of the methods because they should all give you the same answer. Okay, now on 3.2.3 we have 2x plus 5y equal 3 and x equal 5y plus 9. So it's already solved for x, and so I'm going to plug this expression into x. So I go 2 times 5y plus 9 plus 5y equal 3. Then you want to distribute and combine like terms. So I have 15y plus 18 equal 3. Now subtract 18 from both sides to get negative 15, and then divide by 15 gives you negative 1. So then I go back to the original x equal 5 times negative 1 plus 9, which is negative 5 plus 9 is 4. So this is 4 negative 1. So I just used the equation that was already solved for the variable, because that's what makes the most sense. So just telling you, be careful, because on this one it's already solved for y. So you get x, and then you have x comma y. On this one it's already solved for x, and so you solve and get y, then you plug in to get x. And so again it's x comma y. So on both it's x comma y, but the order that you get things, changed. But again, that doesn't really matter. Okay, the next one, instead of having it like y equal or x equal, they make you work. So this one says 4x minus y equal 1 and 5x plus 2y equal negative 2. So out of your choices on the variables, this has 4x, this has negative 1y, this has 5x, and this has 2y. You could have chosen any of the variables to isolate, but I chose the easiest one, which is when it ever has a negative 1 or a positive 1. Otherwise, you would end up having to multiply, like as a quick example, I'm not going to write out. If you were trying to cancel the x's for this one through elimination, then you'd have to multiply this whole equation by negative 5 and this whole equation by positive 4. And then they'd cancel out. And you don't really want to do that. Also, like if you were to just solve it through substitution, which is what this is about, you could have had 4x equal y plus 1 and then divided by 4, so you have fractions. So again, just be very careful about which one to choose. I try to choose the easiest one if possible. So here I just subtract 4x from both sides, and then I multiply by negative 1 to both, or you could say divide by negative 1. It means the same thing in this case. So if you have y is 4x minus 1, then you can plug in, you have 5x plus 2 times 4x minus 1 equal negative 2. So again, notice we already used our top equation, so substitute into the other equation. So we have to distribute the 2 and then work from there, and you get x equals 0. Once you have that, then you can say y equal 4 times 0 minus 1, which gives you -1. So your answer is 0, -1. So again, this ordered pair is what would make both equations true. So again, if you want to do a check, 4 times 0 minus -1 equal 1. This would be 0 plus 1 equal 1. 1 equal 1 is true. And so then for the other one, if you want to check it, 5 times 0 plus 2 times -1 equal -2. This would be 0 minus 2 equal -2, -2 equal -2, which works. So this answer would work for both equations. It's the only one. Our next one is 326, and so we have 4x plus 5y equal 10 and x plus 2y equals 7. So x would be the easiest to isolate, in this case in the second equation. So I subtract 2y from both sides, I get x equal -2y plus 7. So then I plug this into the first equation, sub into the first equation. So 4 times -2y plus 7 plus 5y equal 10. So then you distribute -8y plus 28 plus 5y equal 10. Then you want to combine your like terms. So -8y plus 5y is -3y plus 28 equal 10. So then subtract 28, you get -18. Divide by -3 gives you 6. So that's what y is. So then you go back to this equation. You say x equal -2 times 6 plus 7. -12 plus 7 is -5. So then you make your ordered pair. Again, it's always an x comma y ordered pair. All right. For the next one, it says a student has some $1 and $5 bills in his wallet. He has a total of 14 bills worth $50. How many of each type does he have? So I just started doing this guess and check table to start with. So I'm like, okay, 14 bills, so what about 12 and 2, or 10 and 4? I was just trying to get y as an even number, because if it's 50, then I was thinking maybe I'd need to have like a multiple. 2 times 5 is 10, 4 times 5 is 20, 6 times 5 is 30, etc. But it didn't work out, because even when I did 4 with 10, that'd be 4 plus 20, which is 24. And so then, since the even numbers didn't work, then I just tried 9, and then that'd be 5 plus 9 times 5. 5 plus 9 times 5 is 5 plus 45, which does give you 50. So this is just trying to come up with it algebraically, guess and check. To use the equations instead, you'd have x plus y equal 14, because x would be the $1 and y would be the $5, equal 14 bills. So this would be like your item equation, and this would be your money equation. So item equation and money equation. So a $1 bill is worth 1, so your coefficient is 1. A $5 bill is worth $5, so you put 5y. And then the other money part was 50. So on this, what I then did was I said, I'm going to use the second equation this time just to be different. I could have solved for x or y on the first equation, and it would have been very simple. It would have been x equal 14 minus y, or y equal 14 minus x, and then just plug in. I decided to show you that this way would work also. So when I did negative 5y plus 50 and plugged that in to this equation, negative 5y plus 50 plus y equal 14, then negative 5y plus y is negative 4y, and then subtract 50 from both sides, get negative 36. Divide by negative 4 gives you 9. And then plug the 9 in, so negative 5 times 9 plus 50 ends up getting you 5. So 5 comma 9. Same as what I got in the table. So what this represents is there are 5 $1 bills and 9 $5 bills. All right. Our next one says solve by elimination. Now this is like addition. Basically you need a variable to cancel, and sometimes it's called linear combination. So look for plus and minus a term. So like in this case, plus y minus y, that cancels. So then x plus x is 2x, negative 3 plus 5 is 2, then you divide by 2 and you get 1. And then you plug it in. I just chose the addition equation. It would have worked for both. 1 plus y equal negative 3, then you subtract 1 and get negative 4. So you have 1 negative 4. Our next one is 3 2 12. We have 2x plus 5y equal 13 and negative 2x plus y equal 5. So notice your plus and minus 2x terms cancel easily. So then this cancels. This gives you 6y equal 18. 18 divided by 6 is 3. And then we just plug it in and we get negative 1 for x. So then your answer is negative 1 comma 3. And then on this one, 3 2 14, we have our equation 3x plus 2y equal 3 and 3x minus 2y equal 3. So the plus and minus 2y cancels. You have 6x equals 6, and so then x is 1. Then 3 times 1 plus 2y equal 3. 3 plus 2y equal 3. Subtract 3 from both sides to get 0. So y equals 0. So this gives you the ordered pair 1 comma 0. That's all the time that I have for this particular video. I'll do another one with the other Math Excel.